and welcome to Comparatively Speaking, where we understand the sciences through analogies. And I will not be giving every lesson in my jammies, so you're just going to have to enjoy this while it lasts. Today's brief lesson is on the concept of the isotope. So we know that the atom, which is the smallest unit of matter, consists of protons, neutrons, and electrons. I haven't mentioned it yet, but we can now learn that protons and neutrons are at the center of the atom and electrons are orbiting the outside. Electrons contribute almost nothing to the mass. There's so little. It's almost like your protons and your neutrons are both like you got black beans and white beans in there. And then, so like a little pinto bean size, and then your electron would be like a speck of pepper for comparisons, 10,000 times smaller and less massive than the protons and the neutrons. So when we talk about atomic mass, we really just add up the protons and the neutrons the same way that, like, if you were a wrestler and you were going to a weigh-in and you stepped on a scale and they said, oh, wait a sec, you got like a little fruit fly on your head, we got to do the weigh-in again. They wouldn't do that. The electron is so little, it's like the fruit fly, it doesn't count for mass. So mass is protons plus neutrons, whereas atomic number is just the protons. So that's the identity, tells you, what element it is, and then we're going to determine its mass. Now, that's going to be kind of like a whole nother lesson on atomic mass, but for the moment, the term that we need to learn in order to understand atomic mass is the word isotope. So you hear the word isotope and you cringe and you're like, oh, this is science. I don't like it. I know this stuff. I don't want to do it. So let's demystify the word isotope. Isotope means it is the same element. It's got the same number of protons. Like every atom that you're looking at has that unique number of protons, maybe differs in the number of neutrons, and therefore the mass is a little bit different. Carbon is a great example because carbon has atomic number 6. It has 6 protons. Most of the carbon on Earth has also 6 neutrons for a mass of 12. But you get the occasional isotope where you have carbon with 7 neutrons for a mass of 13, or carbon with 8 neutrons for a mass of 14. Gets heavier, also becomes kind of unstable and likely to decay. So that brings us to the analogy for this one, which is that imagine you are bringing things in for a canned food drive and you've got your black beans, your protons, and your white beans, your neutrons, in cans, right? So you got armloads of cans. That's your nucleus where you're holding all these protons and neutrons, just a whole bunch of cans together. Pretty stable, right? You're loaded up, you're gonna carry them. And that's the atoms walking around with their protons and neutrons in the nucleus. But let's say that I throw a couple extra cans on top of that pile that you're already carrying. Now the cans that I throw are gonna be neutrons, right? Because if I gave you extra protons, you would be a different element. So I'm just gonna throw a few extra cans, the white beans, right, the neutrons, but maybe now you're gonna start to drop some of your cans. And you're not necessarily gonna drop the ones that I threw at you, right? If you're carbon, you're all right. You maybe get a few extra cans, maybe you drop a can or two, and you still hold together, you're still carbon. You get a little lighter. That's a form of radioactive decay. That's what they call it. But let's say you're uranium, right? And you're this huge, heavy, you've got 92 protons, you've got like 146 neutrons. Well, now when you start dropping cans, you don't know whether you're dropping white beans or black beans, you're just dropping cans, and like it could be that you lose, this can, that can, you lose some neutrons, maybe you lose a few protons. That kind of radioactive decay is going to produce a new element, right? Because the proton number changes, it changes the element. So it progresses down from being uranium to being these other elements that are kind of like earlier on the periodic table, because radioactive decay is the nucleus dropping its stuff, dropping its cans, and not necessarily just its extra neutrons, dropping like maybe some neutrons, some protons as well. So that's the analogy. I know that you have your choice of teachers who will gesticulate with their arms and not use the whiteboard. So I'm very grateful that you've chosen this teacher for your chemistry needs. Have a good night.